Hi, let's talk about the abdominal aorta and its branches. In this video, we'll discuss the major arterial branches of the abdominal aorta, and we'll also touch on some of the major visceral branches of the abdominal aorta branches, in particular, branches of the celiac trunk and the superior and inferior mesenteric arteries. So first, let's start at what is the abdominal aorta. So the abdominal aorta is a continuation of the thoracic aorta. Sometimes these two are referred to as parts of the descending aorta, and they are divided by the diaphragm. When the descending aorta traverses the diaphragm at the level of the 12th thoracic vertebrae, it then is called the abdominal aorta. The abdominal aorta is going to bifurcate at approximately the level of the 4th lumbar vertebrae into the right and left common iliac arteries. But there is tremendous variation there. If we turn our attention to this cartoonish transverse section of the abdominal aorta, we can gain an appreciation for the directionality of some of the major branches of the abdominal aorta. So first of all, the visceral branches can take one of two pathways. The major visceral branches typically exit the abdominal aorta anteriorly, whereas the minor branches may exit the abdominal aorta laterally. And then finally, the parietal branches, or the branches that are going to predominantly serve the body wall, are going to exit the abdominal aorta posterolaterally. Keeping in mind that aorta is going to rest just anterior to the vertebral column, which we can see in this illustration here. So let's discuss these branches as groups, and then we'll get into the granular details of each. So first of all, the anterior branches to the viscera, these are the major branches of the abdominal aorta. We have at approximately the T12 height, the celiac trunk. That celiac trunk is going to supply the foregut with blood. Then we have the superior mesenteric artery, or the SMA. The SMA exits at approximately the level of L1, and that is going to supply the midgut with blood. And then finally, we have the inferior mesenteric artery, or the IMA, which generally is a branch at about L3 or so, and this one tends to be a little less midline than the celiac and the SMA. And that is going to supply the hindgut with blood. Now, laterally, we have several pairs of arteries, starting somewhat high, generally about the level of L1, sometimes lower T12. We have the middle suprarenal arteries, both left and right. The right one just isn't drawn on here, but it would be that way. The suprarenal glands actually have 3 sets of arteries that typically supply them, and it's only the middle that come directly off of the abdominal aorta. As we move inferiorly, at approximately the level of L1, this would be the transpyloric plane, we have the renal arteries, and these tend to be very large arteries that go out to supply the kidney with blood and supply blood to the nephrons of the kidney for their role serving as dynamic filters of the blood. And then this is variable sometimes between the level of L1 and L2, with the left generally being higher than the right. We have the gonadal arteries. These gonadal arteries are sometimes specifically referred to as either the ovarian or the testicular arteries, but it's probably best to leave them as the general gonadal arteries because they're the same arteries no matter how you slice it. Then finally we have the parietal branches. So there's tremendous variation here, but at approximately the level of T12, keeping in mind that the diaphragm is a dome, and at the posterior margin of the diaphragm where it meets the body wall, there's going to be quite a large recess in the thoracic cavity there. So you can imagine that the diaphragm sort of sharply descending back towards that posterior body wall. At about that T12 level is the subcostal arteries. So these are the arteries that are exiting from the abdominal aorta below the level of the 12th rib. Somewhere in that vicinity, we also have inferior phrenic arteries, and these inferior phrenic arteries are quite variable, but they rise from the abdominal aorta somewhat high to supply the diaphragm with blood. There are also somewhat regularly segmental lumbar arteries, 3 to 5 lumbar arteries throughout the abdominal aorta that are moving more posterolateral back to serve the body wall. So let's look at more of the details of some of these major visceral trunks. So at the T12 level, we have the celiac trunk. The celiac trunk doesn't have much of a trunk leaving from the abdominal aorta. It's immediately below the diaphragm, and its branches tend to arise almost like a flower right from the abdominal aorta itself. The celiac trunk is serving the foregut or the derivatives of the embryonic foregut, so all the way up from the abdominal portion of the esophagus down through the proximal part of the duodenum and everything in between. And that everything in between is going to be the stomach, the pancreas, and the spleen. So let's take a look at some of these branches, and we can look at some of their finer scale branches. So we could really start anywhere. So let's start at the beginning of the list with the left gastric artery. To really appreciate this anatomy, it would probably also be helpful to discuss some of the features of the gut tube. And so as we look at the stomach here, I want you to see that there is a curve here and a curve there to the stomach. This concave curve is the lesser curvature of the stomach, and this convex curve is the greater curvature of the stomach. And so when we look at the left gastric artery, it comes out and it wraps around, and it's going to predominantly serve a part of the lesser curvature of the stomach. And it's going to have a very important anastomosis or connection with another branch that we'll soon describe called the right gastric artery. So the gastric arteries are serving that lesser curvature, and they anastomose. They share blood supply. There's also a splenic branch of the celiac trunk, and the splenic artery is a fantastic, impressive artery. It's large, it's tortuous, meaning it's kind of corkscrewy. It's oftentimes embedded in the pancreas, and it shoots off left laterally out towards the spleen. It will send a couple of branches inferiorly to supply the pancreas, but that's really beyond the scope of this video. As it moves out towards the spleen, it's going to send some short gastric branches to the stomach, some splenic branches to the spleen. Hey, that's where it's going and how it's named. And then finally, this artery here called the left gastro-omental artery. That left gastro-omental artery is going to serve the greater curvature of the stomach, as well as the greater omentum with blood. That left gastro-omental is going to be met with a right gastro-omental for an anastomosis. So gastric arteries serve the lesser curvature, whereas gastro-omental arteries serve the greater curvature of the stomach. So we've discussed the left gastric and the splenic. Let's talk about the common hepatic artery. One thing that is very important to understand is that there is a tremendous amount of variation in how these arteries branch. And so this illustration is somewhat of a deviation from the typical pattern. And so the typical pattern of the common hepatic artery is that there is a gastroduodenal artery. And I guess you can figure out what this is going to supply: gastro, stomach, duodenal, duodenum. And from that gastroduodenal artery, there are several branches, but the one that we're going to care about here is the right gastro-omental. So here is that gastroduodenal artery descending down, and the right gastro-omental artery is coming off of that. So there are also branches to the duodenum and the head of the pancreas that can anastomose with the SMA, but again, that's too fine a level of granular detail. The other major branch is called the hepatic artery proper, or just HAP, HAP for short. HAP is going to typically give off the right gastric artery. That's the one that's going to form the anastomosis with the left gastric artery to serve the lesser curvature of the stomach. And then HAP will continue on and branch into left and right branches of the hepatic artery proper to serve the liver. And generally, the cystic artery, which serves the gallbladder, is going to come off of one of those branches, but it may come off another part. It could come off HAP directly, it can come off the gastroduodenal. You know, it's very labile with respect to where it's coming from. So right gastric, and then right and left branches. Typically off of that we have the cystic artery. So that's the celiac trunk, and to see this in dissection you really have to dissect deep. That abdominal aorta is retroperitoneal, so it is in the retroperitoneal space, and you'd have to dissect down to see that celiac trunk. The next major visceral branch is the superior mesenteric artery. The superior mesenteric artery is coming off of the abdominal aorta at about L1. It's going to head anteriorly over the left renal vein, so it's got a classic anatomical relationship there. It's going down just posterior to the neck of the pancreas, along with this portal vein there that we can see. And its first branch is a minor branch, but an important one, called the inferior pancreatico-duodenal artery. That inferior pancreatico-duodenal artery is going to supply the head of the pancreas and the duodenum with blood. and it's an important anastomosis to the gastroduodenal artery. Gastroduodenal. That's coming from the common hepatic artery, so celiac. Then we have quite an interesting cascade of arteries. So here we have the main body of the superior mesenteric artery, the SMA. Coming off of this left laterally are the intestinal arteries, specifically jejunal and ileal arteries supplying the jejunum and the ileum specifically. So these are parts of the small intestine that follow the duodenum. Coming off the right side of SMA are the colic arteries. So we'll have a middle colic artery. So that's the middle. Then a right colic artery. That's the right. And then an ileocolic artery. That's the ileo. And that ileocolic artery wraps down around and forms this arch with the SMA. That's impressive. Now, these are called the colic arteries because they are supplying the colon with blood. Now, they don't supply the colon directly. They actually dump their blood into what's known as the marginal artery. The marginal artery I'm tracing all around here. It goes around the margin of the colon or the large intestine, and then there are branches that extend from the marginal artery to the colon itself. So the middle colic is supplying the region of the transverse colon. The right colic is supplying the region of the ascending colon. And the ileocolic is supplying portions of the ascending colon, the cecum and appendix, as well as parts of the ileum. So it's quite an impressive amount of blood flow. The next branch is the inferior mesenteric artery. So here we can see a little bit of SMA. It's been reflected away. Here's our abdominal aorta, and then kind of coming off left laterally is the inferior mesenteric. And there are going to be three major branches here. There is a left colic, a sigmoidal, and that sigmoidal usually ramifies into 3 to 5 branches, and then a superior rectal artery. The left colic is going to feed into the marginal artery. And we can see that marginal artery coming down here. And we can see the branches of the left colic feeding into that marginal artery. So this marginal artery is going to be such an important anastomosis between the SMA and the IMA. Sometimes these sigmoid arteries can feed into the marginal arteries as we see there, but usually they're going directly down into the sigmoid colon, which is this S-shaped portion of the colon. And then the superior rectal is diving deep to supply the rectum with blood. That leads us to our assessment question, and that is anastomosis between the SMA and IMA is common through which vessels? A, left colic artery, B, middle colic artery, C, marginal artery, D, right colic artery, E, sigmoidal artery. This can be a tough one to answer because you can make a case for any of these to really be involved in the anastomosis, but the best possible answer here would be C, the marginal artery, because it is running around the margin of the large intestine and branches of the IMA, such as the left colic, sometimes the sigmoidal, but not always, and then branches from the SMA, the middle colic, and the right colic are going to be feeding into that. So, best answer, marginal artery. Is it possible that these other arteries are involved? Yes, but not as much as the marginal artery. Thank you very much for your time.